Listen-only mode.
Okay, good morning, good afternoon, depending on where you are. This is David Silverstein. We'll go ahead and get started here. Looks like we've got most everybody that registered already logged in here today. We might be expecting one or two others. The subject of today's webinar is titled Go Green. Now, I've got to tell you, my first instinct when we discussed doing this topic was that I wasn't so excited about it. And the reason is that the concept of going green has become such a cliche. It's become, oh, I'm getting a message that you're not hearing me. Let me do a sound check here and make sure I am being heard. Okay. Okay, looks like the sound is working fine. So the concept of going green is gotten so much buzz, it's become such a cliche that it's almost lost its meaning before it's even started. And so I want to try to put some deeper understanding around what it really means to think about going green, and in particular talk about how we use our process improvement tools to do that. Before I get too deep into things here, let me go ahead and put my contact information up there for you. If anybody, I find I get a heck of a lot more questions via email after our sessions than I do during these sessions, so I want to make sure everybody's got my email and contact information, and I'll put that up once again near the end. So, as I said, going green has almost become a cliche. It's lots and lots of buzz, lots of hype. I did an analysis years ago when I started researching the subject of innovation on how innovation was quickly becoming a buzzword, and I went out and I plotted the number of times the word innovation had showed up in the Harvard Business Review starting in 1998 through I think it was 2007, and you could see an exponential rise in the number of times the word innovation was used across articles and the titles of articles. Well, I did something similar on the concept of green and green technology just the other day, and saw very, very similar results, although the buzz didn't really start in a big way until, well, it was probably 2004, 2005, about the time when the price of oil was starting to go through the roof. So once again, you see companies out there rebranding themselves around green. These are some of the different logos. As many of you have created logos over the years to support your Lean and Six Sigma programs, as an example, companies are now inside their own companies creating special green logos to support their own environmental efforts. Internal communication departments are being turned to the effort of propagating the green message. We're seeing more and more recycling bins show up and so on, signs. People, I get emails from people all the time with a little message at the bottom saying, please consider the environment before printing this email. And the question is, do any of us really understand what it really means to go green? So I want to start out by talking about it from a business perspective. And before we talk about going green, let's just talk about business in general. What are the fundamental principles of business? And I've boiled them down into what I believe is three fundamental principles. If you go into any first-year business book and read about what the essence of business is, you'll find just a few things. Business is the efficient allocation of scarce resources, often starting with capital as that scarce resource, capital coming from some investor looking for a return on the risk they're willing to take on their capital. But one way or another, business is about the efficient allocation of scarce resources, capital, human resources, natural resources. And we allocate scarce resources to solve the problem or problems of one or more customers. And those customers have to be willing to pay some fair price for the solution that we provide. Without any one of those things, without being paid a fair price that allows us to generate a profit, without customers that have some need, and without some investment on the front end, we don't have a business. So when we look at those three principles of business, ask yourself, where does going green come into play? And you quickly come to the conclusion that the focus of green projects is the efficient allocation of those scarce resources, and in particular we're talking about natural resources. So any kind of project or effort that a company embarks on to improve its environmental friendliness, to go green, is just about always about either reducing the consumption of some resource or reducing the byproduct that comes from the consumption of that resource. But it's always got to do with resources. Oh, excuse me. Now, really going green is not just about using less of something, but we also have to think about more of something. And the more I want to talk about is more of nature. And I think this is the missing component in most green discussion. Because when we just talk about things like using less of something, any improvement that we make in our business can be spun to sound like a green project, and we did it to improve the environment. I remember a project a couple of years ago with a client that reduced the consumption of paper by about $4.5 million by eliminating marketing materials that they concluded were never even looked at by customers. And sure enough, it was done to save the $4.5 million in paper and printing costs. But of course, once the project was done, the press release went out talking about how wonderful they were because they had saved the environment and saved all of these trees. Well, that had nothing to do with why they had really worked on the effort in the first place. It was all about money. So I want to turn the focus of going green not just to reducing our consumption of natural resources, but to using nature more to get it done. So some key fundamentals of nature to think about. Number one, nature runs on sunlight. All nature runs on sunlight. Even animals which do not use photosynthesis to make food for themselves, when you look at the whole biological cycle of nature, the energy ultimately comes from the sun because the plants are eaten by the animals and so on. Nature is very efficient. It uses only the energy it needs. So nature is just about 100% efficient. On the other hand, our ability to use energy efficiently is much, much worse. We have tremendous energy loss in just about any way that we make and use energy. That energy is lost in the making of the energy. It's lost in the transmission of the energy. But we're very inefficient. Nature is very, very efficient. Nature fits form to function. In other words, nature is an incredible designer of things. Nature recycles. If you go back and pick up your third grade Earth Sciences book, you'll study about and if you have any young kids in school, you'll study about the biocycle and how nature recycles everything, because things, once they die off, they ultimately break down and go back into the earth as minerals and nutrients, and ultimately are consumed and become sources of food, essentially, for the next generation. So everything in nature gets recycled. Nature is very much about cooperation and symbiotic relationships between animals and animals, between plants and animals. Nature is very much dependent on diversity, where each species of plant and animal has its own place in the ecosystem, and that diversity is critical to the survival of the system. Nature demands local expertise. In other words, nature adapts itself to local climates, whether that climate has to do with differences in temperature, differences in humidity, differences in the other nature that is around, in other words, the foliage and so on. And nature, over time, weeds out waste and excess. So, for example, if there is an excess of some kind of growth or foliage, nature may weed that out through a natural-born forest fire that begins with lightning and burns down the forest and turns that excess back into the nutrients needed in the ground. But one way or another, nature over time has these natural feedback systems built in order to weed out excess. So if we can keep these principles in mind and not just focus our green efforts on using less of stuff because we want to save money, we're really starting to get at the essence of what it means to go green. So let's turn our attention to business. Going green is good for business. There's been whole books written on this subject. There's been lots of articles written on this. This is kind of the tagline that consultants use. Going green is good for business. So why not do it? But the question is it really good for business? Well, the reality is that going green for the sake of going green, or because you want to make some kind of a statement that you're smart and you're a good recycler, for example, often actually costs more money than we think. You know, when the recycling craze started, most materials that were allocated for recycling wound up in different landfills than the rest of the trash because we didn't actually have the technology to do the recycling yet. Because we often jump on things before they are economically feasible. So we have to think about, when we want to do something that sounds or feels green, we have to ask ourselves, is it really? There's tremendous debate right now about biofuels and about fuel from grain and corn, and whether or not it's really more cost effective and whether or not it's really more friendly to the environment, and what are the long-term economic costs to using up our land to make fuel versus making food, when the price of food right now is going through the roof because of the growing middle-class populations in places like China and India. So why do companies really go green in the first place? Well, they do it for a number of reasons. If you were to take all the different statements that you could find, and I do this by going through annual reports of the Fortune 1000 kind of companies, all publicly available on the internet and all, but go into their annual reports, and many companies are making statements these days about either social responsibility or environmental responsibility or good corporate citizenship. And if you were to affinitize all the reasons they say they're doing it, I get down to these 5. One, they do it to save money because it's good for business. In other words, we're going green because it's good for business and it makes us more money. Some do it to make some kind of differentiating statement to their customers. In other words, they know or believe that their particular customer demographic cares about whether this particular supplier is environmentally friendly. So they do it to make a statement to their customers, not because they necessarily care about it themselves. In some cases, they do it to actually meet the requirements of their customers. So for example, Walmart is fast becoming known for imposing certain environmental standards on their vendors. So the vendors have to do it. They need to reduce their carbon footprint, and they need to show how they're being environmentally friendly. Some just do it to make a statement about good corporate citizenship to the world. Maybe that's a public utility, and they're simply they want to make a statement to everybody. And some are doing it to get ahead of the curve, to be better positioned in the future, because they really do believe that when done the right way, all of these other purposes can be served. And they understand that, well, it may not be very economic today, there's a learning curve that we all have to go up, so they want to get started. And in those cases, those companies often make much smarter, more strategic, and smaller investments because they're doing it as much to learn as they are to make a real impact today. And I think those are perhaps the smartest companies. Now, how do you go about doing it? Well, any of you who have studied any approach to process improvement has had this very simple equation drilled into your heads. Y is some function of X. In other words, a process has an output, and that output is a product of some combination and transformation of inputs. And so we can use this very same equation to understand the environmental impact of any kind of process, whether it's a manufacturing process or a service process. Now, how can a service process have an environmental impact? Well, think about the local bus service. So it still takes energy, it still takes resources to deliver services. So when we dig into y as a function of x, we can look at the kinds of inputs that go into our processes. Energy. Nothing gets done without energy, whether it's electrical energy, whether it's gas to produce heat, or whether it's human energy. Raw materials, manufactured materials, labor. So think about all the different inputs. What are the other inputs that you see going into your processes? They go through some transformation, and then there are outputs. But as I said, human processes of any kind are not nearly as efficient as the processes of nature. And so we may get our finished goods out, but we also get byproducts, airborne byproducts, waterborne byproducts, scrap that has to go to a landfill, wasted energy. What other byproducts do you see coming out of your processes? So we can optimize a process for its environmental friendliness, make it more green, by either reducing the inputs that go into it, the valuable inputs, or by reducing the wasteful outputs or the undesirable outputs. And to do that, I constantly turn back to the real, what going green really means, which is to really understand nature and how nature would execute a process. So sure, we can reduce less energy by turning the lights off in the building earlier, or by putting in motion sensors. But do you know that every investment in a motion sensor, or nearly every investment in a motion sensor to turn lights off when people are not in the room, is actually something that makes you feel good and doesn't really have a payback? Because the energy that went into harnessing the raw materials, the metals, the plastics, that go into that motion sensor, the energy necessary to manufacture it, to deliver it to you, for somebody to install it, almost never has a real payback, but it sure makes us feel good. Now, sometimes the payback can be calculated as a 20-year or a 10-year or a 5-year payback period. Somebody says, well, that makes good sense. That's a good investment. But it's really not. Let me tell you why it's not. Suppose you have a room, a well-lit room, and you put a motion sensor in to turn the lights off, and somebody does the calculation and says, the payback on this motion sensing technology is 5 years. So in 5 years, based on the current cost of electricity, we will have recouped our investment. So we should get the motion sensors. Well, what's being neglected is what's called the technology curve, the rate at which other complementary technologies are changing. So that may have been based on the assumption that the room is filled with 60-watt incandescent bulbs. But already available on the market are compact fluorescent bulbs, the equivalent of which would have taken about 12 watts. In my house, I've already converted to LED bulbs, so a 60-watt equivalent takes about 7 watts. And so all of a sudden, the payback period for that motion sensor has moved from 5 years to 20 years or 25 years. And it just doesn't pay. So, anytime that you're looking at long-term paybacks, and maybe it's solar panels going on the roof of your office building, and the payback period you're looking at. But that assumes that there's not going to be any other improvements that come along earlier in that 10-year payback window. And very often we also neglect the maintenance that's going to be necessary to clean those solar panels, the ones that are going to be broken due to the hailstorm. So if we're not really, really smart about how we go green, going green can serve the purpose of making statements to customers, satisfying demands of customers, making statements to the market, but rarely are they really, truly cost-effective unless we start to consider nature. See, let me just talk about nature a little bit more for a second. Nature, when we talk about Earth, the Earth is an absolutely amazing and incredibly brilliant place. The Earth is seen fit to design some of the most amazing things you can imagine. The birds, the trees, the oceans, all the things we love and consider beautiful have not been designed by man. They've been designed by Mother Earth. And the Earth has managed to thrive for over 4 billion years. It's progressed and has become a more habitable, more beautiful place over time. And I think this is something we often take for granted. Sometimes it seems like we're trying to outsmart the Earth. But no matter what we do over time, the Earth is going to continue to thrive. In fact, even if we really screw it up, whether it's with nuclear waste from Chernobyl and from Japan and from nuclear bombs, or by creating some kind of imbalance in the atmosphere through excessive CO2 emissions that chokes out life, no matter what we do, the Earth itself is going to continue to thrive. Our existence on Earth is just this one little tiny blip in time, and if we screw it up and it takes 10 million years to come back into equilibrium, to the Earth that will seem like a blip in time. There's been life on this Earth for over 1 billion years. So 10 million years to fix a problem is 1% of that time. The Earth is going to thrive no matter what we do, and we're just not powerful enough to threaten it. What we can threaten is our place on it if we don't do things wisely. And the best teacher we have about how to do things wisely is Mother Earth herself. It's nature. And so I really urge you to plant the word nature into any kind of policy or programs that your company is making to go green. Now let's talk about specifically, green or environmentally friendly projects and how we do go about finding them and executing on them. First of all, I already started to allude to this statement on your screen right now that in many respects all projects are green projects, because all projects when modeled, or processes I should say, when modeled as y is a function of x, in order for a process to be improved, to be something that you might call an improvement project, you're going to somehow be reducing the consumption of some resource or reducing the consumption of some byproduct of that process. I can't think of an improvement project that I've ever seen or been involved in that somehow did not result in the reduction of resources. So if you're trying to reduce cycle time, you're probably reducing energy or you're reducing human energy, labor going into a process, or you're reducing storage space because you're reducing inventory, which of course means there's less building materials required to build warehousing space, and there's less of a heating bill because you've got a smaller warehouse to stock your inventory. One way or another, if you're reducing the cycle time of something, you're going to be reducing the consumption of some resource. If you reduce scrap or increase yield, you're reducing the consumption of resources that go into a process. You're reducing the disposal cost of the scrap that comes out of the process. If you're looking at improving quality and thereby reducing your warranty costs, well, if you need to make fewer replacement products or you need to ship fewer fixed products or components, all of those things, the shipping and so on, it all takes up energy. It all takes, transportation resources. I can't think of a project that at the end you could not sit down and say to yourself, okay, what is the environmental impact of this project? So one thing you could certainly do if you're looking to turn your improvement programs, continuous improvement programs, into something that makes an environmental impact statement, you can put a little footnote at the end of every project that says, here is the positive environmental impact of this project. And you will never have a project where you cannot find some positive environmental impact. It's a similar exercise that many of you have gone through with the financial impact. Most of you would probably agree with me that not all projects are worked for the purpose of a direct financial payback, but all projects do have to make some kind of financial impact on the company, or there'd be no reason to do it. So if you have a customer satisfaction problem, you might not be able to find some kind of hard dollar savings associated with that project, but at the end you can still certainly, through a narrative, explain why it will financially make you a better company, whether it's through better customer retention or increased business with happier customers. There's always at least a soft financial impact. Well, there's always at a minimum a soft environmental impact to every project you can conceivably work on. And when you get good at seeing that environmental impact, I think it's an exercise worth going through. It's not an exercise in semantics. When you put in place the discipline of identifying the environmental impact, what it does is it begins to trigger ideas about how you can have a greater environmental impact in the future. So here are some of the things that you want to look at. If we were to take our typical 8 wastes that we talk about in lean projects, there's 5 of them that we can really start to drive concrete connections between these wastes and environmental impact. Transportation, certainly. Transportation takes energy, and transportation is one of the biggest producers of carbon emissions. So certainly if we're reducing transportation, we can find the environmental impact. Inventory. Well, inventory sucks up natural resources. It results in things like obsolescence, which often causes things to wind up in landfills. Inventory drives the need for more space, more factory space or warehouse space, which has raw materials involved in creating the space as well as energy involved in maintaining the space. Overproduction. When we produce too much too soon, we often wind up with obsolete product, or when we do make defects, we catch them later. Again, we wind up with more scrap, more in the landfill. Rework takes energy at a minimum, and certainly may take spare parts, replacement parts, and so on when we have to do rework, and if the rework is due to defective parts.
Welcome to GoToWebinar, Web Events Made Easy.
To ask ourselves, why are we recycling in the first place? And then processing things. Overproducing, again, takes energy, human energy, real energy, gas, electricity, and so on. So we can look at the types of waste that are generated by our process, and then we can, through cause and effect analysis, we can get to the environmental wastes. When we start focusing on more green types of projects, you might want to add to your 8 wastes. You might want to change your categories, just like we often do on a fishbone diagram, where sometimes you have different categories you use to spur your brainstorming, whether you're looking at manufacturing processes or you're looking at transactional processes. Similarly, when you look at your 8 wastes, you can flip the page and maintain a separate set of wastes to focus on, and which energy consumption, emissions, scrap, disposal costs, and create your own list of what are the kinds of wastes or the kinds of byproducts that we're trying to reduce. And by having a list to turn to, again, it will trigger the thinking. And so these are just some of them. Now, in order to actually find and identify these wastes, my recommendation is you use the same kind of value stream map or process map that you use today. So we don't need to use new tools. But what I would do is add a dimension, and at every step in my process, I would look to identify the environmental impacts of my value-added or non-value-added activities, or in my process, and what is the environmental impact of each step in my process. If you're creating something like a swim lane diagram, add another column to identify environmental impact. In other words, start to sensitize yourself and your people to the different types of waste that contribute to your being a not-so-green company, and use your existing tools simply by adding dimensions. You could go through and use an FMEA if you're familiar with how to use FMEA, and you can look at FMEA from a different perspective, which is where can we fail to produce a clean output, and what are all the ways that can happen, and what's the impact of that, and so on. What's the severity, the likelihood that it happens. So we don't need a whole new set of tools. What we need to do is we need to use existing tools and just modify them to give us a slightly different focus if becoming more environmentally friendly is one of our goals. So listen to the environmental voice of your process. So sometimes we talk about listening to the voice of your employee or the voice of your customer. Well, now listen to the voice of nature, or listen to the environmental voice of your process, and use the very same tools that you use today to do it. The next thing to think about is developing a new set of metrics. Metrics that drive your environmental footprint. So carbon emissions is one, and that is the one that we talk about most these days. But there are many metrics that we can look at that will help sensitize us and help identify for us where there are opportunities to reduce the consumption of scarce resources or to reduce the byproducts, the outputs of our processes. So things like energy, raw materials, water is certainly one of our scarce resources today, is becoming more and more produced. So there's the things we use and there's the things we produce. There's our inputs and our outputs. You know, on the output side, you know, do you measure waste? For example, you may measure the cost of electricity. Certainly energy has become so expensive, many companies monitor their energy bills and they look at ways of saving energy, but very few companies actually look at ways to recycle energy. When you have an inefficient process, a process that say uses 70% of the energy that comes into the plant, where does the other 30% go? Well, generally speaking, it usually goes to produce heat somewhere. And all too often we're then using other electricity to cool wherever that heat byproduct is. But what in your plant or what in your operation actually demands heat? And how can you repurpose that heat? And I'm actually going to show you an example of that in just a little bit. But by putting in place ways to look at a different set of metrics, we spawn a different set of ideas as to what we can do with all of this waste, new recycling ideas, for example. Other areas of focus where you might find really good, you know, so-called green opportunities. Take a look at the environmental regulations that you are being subjected to. Often that's the domain of an environmental health and safety expert, and something nobody else pays attention to. But as we work to improve our environmental footprint, we need to become all more sensitized to those things. Transportation costs. There's been an unbelievable amount of work done by companies to reduce the consumption of fuel used for transportation. And I've seen some really, really interesting studies over the years. For example, a few years ago, a big trucking company set out to study the fuel efficiency of its drivers to figure out if some drivers were more fuel efficient than others. And sure enough, this big trucking company found that women drivers, female drivers, turned out were consistently more efficient than male drivers. And so when they went out and studied that in more detail, they found that the men tend to have lead foot. Now, not that women don't drive fast also, but women are a little bit more patient when starting up, say, from a traffic light. You know, a big truck takes a lot of time to accelerate. Men tend to put their foot down a little harder on the gas, and all that gas is being wasted until the truck has an opportunity to accelerate. So they didn't find that the women drive at slower speeds, but they found that they accelerated a little bit more slowly, and that made them much, much more efficient. I believe it was UPS that a couple of years ago started mapping out routes that would allow their drivers only to make right turns, because we all know that in this country, with a few exceptions like New York City, you can make a right turn on red. So there's much less waiting and idling time at lights, so it speeds up the routes, and it requires less idle time, therefore less wasted fuel burning. But imagine mapping out routes where you primarily only make right turns. So you know, there's all kinds of clever and creative things that have been done to improve or reduce the cost of transportation and the consumption of fuel and the byproducts that come from it. Electricity, natural gas, water usage. Do you really understand these things in your plants or in your office buildings? Raw materials and parts, that's usually the one area that we do have a good handle on. Chemical wastes and the amount of chemicals we use. Well, we pay for the chemicals, so we pay attention to that, but what else can be done with the waste? So yes, we can look at reducing the waste, but do we also know what else can be done with the waste? You know, are there other lines of business that we can get into actually using our byproducts, our wasted time, our wasted energy, our wasted space? There's been some great examples of companies figuring out how to get into whole new lines of business by making use of their wasted time and capital resources. For example, a big company in the business of making cast iron wood-burning stoves. Used to hire temporary workers in the winter when the business really picked up, and they'd have to lay them off in the summer, and the company was doing fine and was profitable, but decided that it had all this wasted space and energy and capital resources and human labor in the summer, and there just wasn't enough demand for stoves, so they got into the barbecue business. And because the capital investment was already there, they were able to get into the barbecue business very cost effectively and grow a whole new part of the business with very, very little investment. So we look at the resources that we have available and ask ourselves, how else can we get value out of them? Space. So there's lots and lots of different areas of focus. And so where many of us have been trained, acclimated to asking certain questions to find money-saving kinds of projects to use our Lean and Six Sigma tools and similar types of tools. We've got to learn to ask a different set of questions and look at a different parts of the business in order to find the really green opportunities. And it just takes time. Challenge your assumptions, existing paradigms. So I'm going to give you some examples of some of the kinds of things companies have done by really asking the hard questions, by challenging the way things are done. So here are some application examples. Reducing fuel consumption and the emissions. A big global energy company using its process excellence tools to optimize loads of refined product from refinery to terminal, saving fuel and personnel. So what does that mean? It means picture things like loading big rail cars and figuring out how to optimize loading of those rail cars in order to reduce the number of rail cars that you have to use in order to get your product from the mines or from the processing plants to where they're going. That's an example of a project that we would have worked on 30 years ago, 20 years ago, 10 years ago, or yesterday, and we did it to save money, but has a big impact on the environment. Combining surgical supply shipments to save fuel and paper and packaging materials. So historically, this particular manufacturer of surgical equipment would pack the scalpels in one type of package and scissors in another type of package. And what the assumption they had to challenge is that when a customer orders a scalpel, all they're ordering is scalpels. Because the way their inventory system was set up, the way their order management system was set up, you would order things by the category that they fell into. But what they realized was companies usually periodically replenish their inventory of surgical supplies. So it's not something they do every day. Maybe it's once a month or once a quarter. They take an inventory, they see what they've used up, they order. And so they realized that they needed to really focus on the way the customer orders things as opposed to the way that they maintain inventory. Historically, scalpels would be made in one plant and scissors would be made in another plant, but it turned out that customers always order those things at the same time. So by realigning the manufacturing, the way they manufactured to be more in line with the way customers ordered things, they were able to significantly reduce their own logistics costs, shipping costs for the customers, but it required changing assumptions. Rather than just doing what they were doing a little bit more efficiently, rather than figuring out how to make scalpels more efficiently, how to reduce the size of the packaging so you can put more scalpels into a smaller package, they completely realigned the way they manufacture to line up with the way the customer buys things. Lots of companies focusing on doing this today, which is reducing air travel. But come on, let's be honest, they're doing it to save money. Now, they can certainly tell us that they reduced the company's carbon footprint by 50% by reducing air travel by 50%, or traveling 50% fewer air miles, but it's done for the purpose of saving money. And I can't really come up with a project that we don't first and foremost do to save money, and then as an afterthought find our improved environmental impact that's resulted from it. Doesn't mean we can't, though. Doesn't mean we can't, but there's no reason to. We shouldn't do anything in business that doesn't somehow make us a financially better organization. Reducing the consumption of electricity, gas, water, and so on, all the typical natural resources that we talk about. Lots and lots of projects. So what most of these projects are projects that my clients have worked on, where they've started saying, we want to understand the environmental impact of the improvements that we make. So I could go through lots and lots of examples, but you can look at all of these and say, well, these are the same kind of projects that we work on. So what I want to really do is I want to turn your attention back to what I was talking about before. I want to turn back to what I call the really green projects, which are the ones where we turn our attention back to nature and the way nature does things. And we do things not just by improving a little bit, not by just reducing our consumption of something or reducing the byproducts, but really starting to get smart, really starting to get creative, really starting to get innovative about the way we improve our environmental impact. So here's a story that came out earlier this year, and the title of this is Swedish Company Harvests Body Heat to Warm Its Buildings. What this company figured out is that in big buildings there are often concentrations of people. In this case, we're looking at a big central rail station in Stockholm, Sweden. And what they found is that even in the dead of winter, there were parts of the building that were so heavily populated by people, and people that were walking fast and in a hurry to get to their train, so their bodies are generating lots and lots of heat, that they were still actually cooling parts of the building even in winter. At the same time, other parts of the building or a building across the street would be spending a lot of money on heating it. So rather than cooling this building, cooling this building and heating the one across the street, what they found ways was to cross-connect the ventilation systems and to harness the heat in one building to heat the other building that actually needed it. So conservation of heat, a basic principle of physics, but they weren't reducing the amount. This wasn't a how do we make our heating system more efficient kind of project. This was a how do we come up with a completely new and novel concept in order to consume less energy. All of that body heat was otherwise going to waste. There's a science known as biomimicry, which is where we study the way nature does things. Remember all those things I told you about nature, incredibly efficient and well-designed and smart. When we can take a problem that we have and look at it abstractly and map it to a problem that nature has solved, there are some amazing solutions to our problems out there. So one technology being used today is based on studying lotus plants and the leaves of lotus plants, which even in very dirty, muddy, tropical kinds of environments where there's big dust storms and where there's rain, the leaf of the lotus plant seems to stay incredibly clean all the time. And nobody has to come along with some harsh detergent which contaminates the groundwater and erodes the leaf after too many washing. Nobody has to use that detergent to keep the lotus leaf clean. Somehow it's figured out through millions of years of evolution how to keep itself clean. And it's got a texture that is such that it's kind of waxy. It's the actual principle by which it repels dirt is called hydrophobics, and this is now being used to create things like self-cleaning glass. Now maybe some of you remember the product Rain-X, Rain-X was probably a first generation at this, creating kind of a slick, waxy coat so things don't stick to the window. And that was done chemically. Okay? But Rain-X was very effective, and it would last for several months. But it was done chemically by putting a chemical coat on the glass. Now what we're looking at is the crystal structure and how to actually construct glass and other materials with a similar kind of construction to that of the lotus leaf. But the point is that nature has solved this problem a long, long time ago. And we humans have been looking for completely different solutions than nature applies. And you have to say to yourself, well, if it can be done in nature, is there really any reason we can't do it ourselves? And the answer you have to come to is no. We may not have figured out how to do it just yet, but clearly if nature can do it, we ought to be able to figure out how to do it too. The Eco Machine is something invented by a Dr. John Todd, and what it is a wastewater treatment system that instead of using harsh chemicals to break things down, it says, how does nature break down garbage, break down junk? Everything in nature will eventually break down. In some cases it may take days, weeks, months, years, tens of years, millions of years, but nature ultimately breaks everything down. And so what this machine does is it uses a combination of bacteria and fungus, different plants, snails, clams, fish, who really thrive in an environment of waste, and they digest these pollutants. And so it's matching up nature with the problems that nature, man-made problems that nature has already solved. So it's a whole different approach. And so rather than using acids and other kinds of harsh chemicals which are hazardous to our environment, there are ways to do things in very environmentally friendly ways. And the answer always is the same. Ask yourself how nature would do it. And the science of biomimicry is how we do that. Now, let's ask ourselves about something like the lawnmower. How do we make a more efficient lawnmower? And how do we, in other words, use less fuel, reduce the emissions coming off the lawnmower, even the noise pollution? So there's a few different ways to think about the problem. One is, go electric. There's some debate about whether that really improves things because the power plant had to make the electricity. Maybe that's a more efficient way to do it. It's certainly quieter, but you're still using up energy. You can just go for a tune-up, make sure it's really running smoothly, it's got clean oil and all. We can plan a more efficient route, so we can, are we mowing the lawn with the least number of overlapping paths and so on. We can get rid of our grass and rockscape, basically make a garden of rock, but suppose we really want a nice looking lawn. Well, right now, interestingly, the lawnmower companies are all working on coming up with better lawnmowers. So they are trying to figure out how to make more powerful electric mowers because they're quieter and they are more energy efficient. Some of them are working on automated lawnmowers, much like the automated vacuum cleaners you see on advertised on television every once in a while. You can't really just set a lawnmower free to bounce off the walls like you do with the vacuum cleaner. So what you do there is you put a wire around your yard, much like the invisible fence for a dog, but you put a wire around your yard, and then the lawnmower detects when it's getting close to the wire, and a little computer chip over time will map out a route, and you can set the lawnmower on automatic. And that's the direction the lawnmowers are going in. But then there's things like this. Zoysia grass. Zoysia grass is actually comes from a natural source. It's not man-made. It's just harvesting a man-made grass from other parts of the world. One variety of the zoysia grass comes from the shores of Cairns, and it's very, very robust. It grows very, very slowly. It's got very, very thick, deep roots, so it requires much, much less water because it grows much more slowly. Where does most of the water go that goes into your lawn? Well, when you cut it, if you ever noticed, if you bag your clippings, that bag is heavy. So, well, how can this grass be very heavy? Well, because most of what's in those blades of grass is water. So most of the water either evaporates, through the leaves of the grass on a daily basis, or it's actually in the grass. So as your grass grows, and every week you cut off an inch or two, you're cutting off really an inch or two of grass that's holding water. So if the grass grows very, very slowly, it uses less water. Now there's also some new genetically engineered grass that's coming out from a couple of different manufacturers, and that genetically engineered grass grows to about 2 inches and just stops growing. So you don't need a lawnmower anymore. Maybe you mow your lawn, they say once, maybe twice a year, just to kind of smooth out the top, just to give it all that really nice groomed, even look on top. But it basically grows to 2 inches and stops growing. So you don't need to water the lawn anymore. You need to water it very, very rarely compared. So we're using less water resource in addition to making the lawnmower almost obsolete, using much less fuel to run your lawnmowers because it's only once or twice a year, so there's fewer emissions. But we're going about solving the problem more the way nature would solve the problem. There are plenty of plants and bushes and trees that grow to certain heights and stop growing. And the reason those plants and bushes and trees exist is because over time the ones that didn't stop growing in that particular area died off because they couldn't suck enough nutrients out of the ground or they couldn't get enough water. So the adaptability of nature says, well, only the ones that survive are the ones that could get enough of the resources that they needed. And those are the ones that only grow to certain heights. So nature's already solved the problem. Here we are off trying to design better lawnmowers that are a little quieter and a little more fuel efficient when nature has already solved the problem by saying, why don't we just grow the grass to 2 inches and stop? So, the bottom line that I'm trying to deliver here is that, I don't want to see the concept of green process improvements become a cliche where we just start talking about the fact that, well, we use less paper and therefore we're a more environmentally friendly company, or we're saving money by putting a cap on how much air travel we're willing to pay for, and because we do that we're going to call ourselves more environmentally friendly. I think the real green revolution has to really and truly come from a focus on the way nature goes about solving problems. And if we can turn our attention more to nature and through the science of biomimicry, we can really start to become truly green and not just be a cliche. So what might be some next steps for you? Challenge your current approach to continuous improvement to drive more environmental benefit. In the first place, simply by recognizing the impact of the projects you already work on. Seek out other people that have a vested interest, that are stakeholders, that may be tasked with reducing your environmental footprint. Very often that's the EH&S folks. Train key stakeholders on what it really means to be green and how it means to think more about the way nature thinks. Challenge your assumptions and truly become green, because nature is not going to insist that we do it. Like I said, the earth is going to take care of herself even if we screw it up. The only thing, we are not powerful enough to threaten the earth, but we are certainly powerful enough to threaten our own existence on it. So just some additional reading you might want to think about. Very good article that was really written as the Green Revolution was just getting started, a roadmap for natural capitalism, written back in 1999. A much more current article on the impact of sustainability and the financial performance of companies. In other words, why going green is good for business. And then a really great video about 20 minutes long on the science of biomimicry itself and how we use nature to drive improvements in our business. So that's what I had to cover today. You have my contact information there at the bottom of the page, and I will stick around to take any questions or any comments any of you might have. So just go ahead and raise your hand if you've got questions.